In this video, we're going to be talking about exponential functions. They're actually the same thing as power functions. Powers and exponents are the same thing, so if you watched a previous video on power functions, then you got a good introduction. However, we never graphed those, and we're going to spend more time graphing them in this video. So in general, a power function or an exponential function looks like something like this, where one number, the base, has an exponent. It could also have a number in front being multiplied. You could also add things to this exponent, or add more numbers over here to the side. But in general, this is the basic form. And in this form, A does a nice job of telling us if the line is going to point upwards or downwards. So if A is positive, we'll get to that in a sec. And it's also really nice because it tells us what the y-intercept is. And we'll get to why that's true in a second here. But basically that's it. So A could be positive or negative, and that's going to determine whether the graph goes up or down. If A is positive, if A is positive, our graph is going to go up in some way. If A is negative, it's going to go down in some way, and these could be going opposite directions, either up to the left or down to the left. But that's just in general. And B is going to be something we focus on a lot in this video. As long as B is greater than 1, or, so if it's a nice whole number bigger than 1, that's obvious, but a little less obvious is if B is a fraction greater than 1. So sometimes you'll see a fraction that B will be a fraction, and you automatically think, well, it's a fraction, it must be a decay function, which is something we'll talk about in the next video. Not true. If it's a fraction greater than 1, it's still going to be a growth function. So if all of this is true, then we're dealing with an exponential growth function, meaning it's going to point up if A is positive or go down if it's negative. But in most cases, this is our general growth function. All right, let's see what it looks like when we actually graph it. Insert. Here we go. Let's try this for example. So in this example, we don't really have an A. There's no number in front being multiplied. This number that has the exponent is referred to as our B. It's our base. You can think of B for base. And in this case, B is greater than 1, so we should get a growth function. That's what we'll focus on. In order to graph, we always use an XY table, come up with the inputs. I'm going to give you a hint. If you always use 0 when dealing with power functions, that always gives you a nice easy output, because anything to the 0 power is always 1. Now, if we had a number in front right here, that may change our output, but in this case it's going to be 1. And then try 1, because that's another easy one, because anything to the first power is itself, so we get 3. So 0, 1 is a point on our graph, and 1, 3 is a point on our graph. The more you get used to dealing with exponential or power function graphs, the more you're able to just use these 2 points and know what it should look like, get a general idea. I know that it's going to do something like this, but for our purposes in this video, I want to make sure you get a nice idea of what the graph does. Let's use a -1 on the other side there. Anything to the negative exponent would put this number over, or under 1, sorry. So we get 1/3 if it's a -1 exponent. So -1, 1/3, somewhere right in there. And the more left we go with our x values, the more negative our x values go, the smaller and smaller this is going to get, but it's never going to actually touch the x-axis. It's just going to get closer and closer and closer. So far we got something like that. Our next value, 2, if we input that, should give us something really high. Let's see what happens here. 2. So 3 squared would give us 9. So 2, 9. Hops up pretty quickly. So this is our exponential function graphed. And as you can see, what was a here? A is kind of implied right here. It's in the front. It's 1. It's invisible right now. So 0, 1 would be our y-intercept. You can actually see that right there. We'll do another example where we actually have a number here. It'll be a little more clear. The a is the y-intercept, but you can see it there. So in general, a growth function, an exponential growth function, starts off slow and it increases or grows rapidly for every input. On this end, our graph is going to continue to go this way and get closer and closer to the x-axis, but never touch it. And in a few videos, we'll talk about exactly what this line represents. I'll just throw the word out there right now. It's called an asymptote. It is the line that the graph approaches but never touches. And we'll talk more about that in later videos. Let's do another example here. What should we try? Let's do 3 times 2x. So here's our function. So this should be our y-intercept. Let's see if it actually happens. It should also be growing upwards since a is positive. We'll check that out. So again, use 0 first. So plug in 0, that makes this whole thing 1 right here. 2 to the 0 power is 1. And then 3 times 1 would be your output. So 3. So 0, 3 did end up being the y-intercept. Look at that. Alright, let's try 1. That's the next easy one. 2 to the first power is 2, and then 2 times 3 is 6. So that's our output. So 1, 6. Let's go to the left of our y-axis here. Let's try -1. So that would flip this to 1/2. And we'd have 3 times 1/2 now. Well, that's 3 over 2, or 1.5. Either way you like to think about it. So -1, 1.5 is about there. And then if we keep going, it's going to get lower and lower and lower and approach that x-axis or that asymptote. But it's going to grow this way rapidly. So again, we got a nice growth line here, an exponential growth line, very rapid. So hopefully you're getting a nice idea of how to graph little power functions, basically only using 2 or 3 inputs here, and you get enough information to really get the idea of what the line is doing, how fast it's growing, and ideally knowing what that y-intercept is. Alright, let's talk about a different form real quick. Similar but different. So now let's start adding things to our function recipe here. So still a times b to the x power, but sometimes you're going to have exponents, some math happening up in this exponent region, and sometimes you're going to have additional values out here to the right. Basically all those extra things do is shift our graph, so it's still going to be this basic graph, but now it's going to get shifted vertically and horizontally a certain amount. So this h value, we don't keep the sign attached to it. H is going to shift horizontally. It's going to be a horizontal shift. And if this value that gets substituted for h is positive, it's going to the right. It's going to get shifted right. If this h value that gets substituted is negative, and then it goes to the left. But be careful, because if you substitute a negative value in for h, you get a double negative, and so you get a plus sign that happens right there. And so you may think that it's going to shift right, but that's not true. It's going to shift left. It's whatever value is substituted right here. We're not going to include this sign when we're talking about which direction we shift. Okay, that k value is going to be a vertical shift. So moving up or down. If our k value is positive, it's going to go up. And if it's negative, it's going to go down a bit. And it's going to shift whatever units are in place of these letters. So let's try one that looks like that. Let's try this function here. Similar to what we just did, now we're going to add those h and k values here. So it's the same graph as y equals 3 times 2 to the x power. So let's remember what we did for that. We used 0 and 1. And when we used 0, we got 3. When we used 1, we got 6. And we found that if we move slightly that way, it was there. So something like this. I'll change colors on you and show you what happens when we actually shift it or move it over. So this graph is going to get shifted. All the points are going to get shifted to the right because h is positive. We don't include that sign there. So our h value is 1, and our k value is -4. So we're going to shift all of our points to the right one spot and down 4. 1, 2, 3, 4. So that spot is going to go there. This spot over 1, 1, 2, 3, 4, down 4. That got shifted that way. Over 1, down 4. 1, 2, 3, 4. So now our line is doing something like that. So same style of graph, same curve on our line, but it just got shifted to the right and down. Now it's not essential that you graph that first line. Obviously we could have just plugged in 0 and 1 here and just gotten this graph first without paying attention to this graph, but I just wanted to show you how it looks, how it gets shifted, how it's the same shape, same graph, just moved slightly either left, right, up, or down. Alright, so in general those are exponential functions, specifically growth functions, how we climb. We didn't talk about if a was negative, but I'll show you real quick what happens. Really what happens is it just gets going the other way. If a happened to be negative there, it'd be doing something like that. Going in the opposite direction, pointed down. Obviously not very accurate right there, but that was just to give you an idea. I'll let you experiment with a being negative. And yeah, but just use the same process. Use 0 and 1 in your XY table, get a couple points going, get an idea of what the line does, and then you're good to go on graphing exponential growth functions. In the next video we'll talk about the difference between growth and decay. What does a decay exponential function look like? So good luck practicing growth functions.